Good day, everyone. Once again, I welcome you to my YouTube channel. My name remains Guido Academy, and in this particular video, we'll be working on redox reaction. I've done the episode 1 of this. Currently, we are in episode 2 of redox reaction. And for this particular video, I'll be teaching you how to balance redox reaction. Remember, in balancing a redox reaction, it can be done in two formats. It's either in a basic solution or in an acidic solution. The question should be, how do you know if the redox reaction is basic, and how do you know if the redox reaction is acidic? Please sit back, relax, let's get started. Welcome back. If you look at this equation carefully, it says balance the equation in the acidic solution. There's a key word there, acidic solution. Please, like what I said, you can balance a redox reaction based on acidic or basic. So for this very equation, we are balancing it on acidic solution using the half reaction method. In balancing a solution or an equation regarding a redox reaction, there are 4 steps that you must look at. The first step is for you to determine the oxidation number of the element. I repeat, determine the oxidation number of that particular element, or the compound rather. Then the second one, you have to balance the atom. But please, before you go to the second step, there is always an intermediate between the first step and the second step. And that is what we call writing a half reaction. A half reaction. I'm going to teach you how to write the half reaction. Then from there, you have to balance the atom. If the oxygen is not balanced, you have to add water to that equation. And if hydrogen is not balanced, you are expected to add hydrogen ion to that equation. Please, water to balance oxygen, while hydrogen ion to balance what? Hydrogen. Then after balancing the atom, you move to the next step, which is balancing of what? Of charges. And how do you balance the charges? It's for you to add electron to the side that is not balanced. Then lastly, you confirm if the atom is balanced and if the electron is balanced. If the atom and the electron they are not balanced, that means you have to start all over again. But first of all, work with half before you balance the two together. Now, if you look at this reaction closely, silver reacting with this compound to give us this and this. What you should take note of is that the first thing is to determine the oxidation number of the element. We have done oxidation number already. So if you look at this compound as an element, a stable element, the oxidation number of every element or a compound, a neutral element or a neutral compound is 0. So the oxidation number here is 0. The oxidation number here is 0 because this is also a neutral compound. Now there is a difference between a radical, a neutral compound, and an ion. For example, if you see Ag+, this is an ion because of this charge, and it's called a cation. If you see O2-, this is an ion and it's called anion. If you see Na, this is not an ion, this is a neutral element. If you see CO2, this is a neutral compound. If you see CO3 2-, this is a radical. So please take note. And the oxidation of this radical, is -2. The oxidation number of this compound here is 0. The oxidation number of this element here is 0. Here is 2- or -2. While here is what? Is +1. So please take note of the oxidation number of elements, of radical, of ion, and neutral compound. So if you look at this, now you guess, what will be the oxidation number of this element here? It will be -1. Then what about this one here? It will be what? +1. So one of the critical aspects of this is, first of all, move from silver here to silver, then from this here to this. Which of them is oxidizing and which of them is reducing? Remember, oxidation, I can say oxidation, here is reduction. We believe that oxidation is loss of electron. Oxidation is addition of oxygen, while it is removal of what? Of hydrogen. While reduction talks about the gaining of what? Of electron, removal of oxygen, and addition of what? Of hydrogen. So if you can put this in the back of your mind, there is no problem you can solve regarding balancing of redox reaction. So look at this closely. If here is silver 0, which is it is neutral. If silver 0 moves from this to this, it means it has given out 1 electron. So loss of electron gave out 1 electron. That's why it's +1. If you have sodium like this and this sodium moves to sodium plus, it means this sodium has given out 1 electron. Here is 0, here is +1, so you give out 1 electron. If you have oxygen here to give us O2-, minus means it has accepted electron. So in a situation like this, if you look at this closely, this one that gave out electron, this one accepted electron. So the one that gave out electron is usually called what? Oxidation. Why the one that accepted, that gained electron, usually called what? Reduction. So if you look at this silver here, what is happening? Silver gave out one electron. So here, oxidation is taking place. While for the top, here is minus, then became zero. That means he accepted the electron. Then we say reduction is doing what? Reduction is taking place. So if you can easily get one, the other one become very, very easy. Another thing again you take note of is, how many oxygen do you have here? 3. How many oxygen do you have here? That's 1. That means 2 oxygen was removed. And now let's go back. If oxygen is removed, it's called what? Reduction. So from here to here, oxygen was removed. So if you can get this one as reduction, definitely the other one will definitely be what? The oxidation. So if you look at this, we have already done the first step, which is to determine the oxidation number, and the intermediate step, that's where we are going to now. Now let's write the half reaction for this. So we have NO3 minus, it gave us NO, and we have AG 0 gave us what? AG what? Plus. So for the first reaction, it is called reduction, while for the second reaction, it is called what? Oxidation. So the next step here is for you to balance the atoms. So let's check. Let me write the first one here, which is NO3 minus to give us NO. So first of all, how many nitrogen do we have here? 1. How many nitrogen do we have here? 1. How many oxygen do we have here? We have 3 oxygen here. And how many oxygen do we have here? 1. So we already know that the oxygen in this reaction is not balanced. And if the oxygen here is not balanced, what are we expected to do? Add water to balance what? The oxygen. I repeat, you have to add water to balance the what? The oxygen. So therefore, let's write NO3 minus to give us NO. The question is, which side am I adding the water to? Is it this side or this side? Please take note. We are adding the water to this side because this oxygen is lesser or is lower than this one. So we add plus H2O. If you add plus H2O, the next question is, how many nitrogen do you have here? Is 1. How many nitrogen here? Is 1. How many oxygen here? Oxygen here is 3. How many oxygen here? Oxygen here is 2. So it's not balanced. So if I put a 2 here, that means oxygen here is what? Is 3. So the oxygen is balanced now. But there is another useless element that is appearing here, which is hydrogen. So you now come hydrogen. Hydrogen here is 0, but hydrogen here is what? Is 4. It's not still balanced. So what are you expected to do? The question states that if water is not balanced, if oxygen is not balanced, you add water. But if hydrogen is not balanced, you are going to add what? Hydrogen ion. So let's add hydrogen ion to the equation. So you have NO3 minus NO plus 2H2O. So if you are adding hydrogen ion to the equation, you are adding the hydrogen ion to this side. So here we what? Plus hydrogen ion. And how many hydrogen do you have here? Is 4. So you put plus 4 hydrogen ion. So let's confirm. Nitrogen here is 1. Nitrogen here is 1. Oxygen here is 3. Oxygen here is 3. Then let's check for hydrogen. Hydrogen here is 4. And hydrogen here is what? Is 4. So for now, we have been able to balance the atom. So after balancing the atom, the next step we are expected to do is to balance the charge of, you are expected to balance the charge by adding what? By adding electron. Okay, this balance equation, it has been transferred here. So what we have to do here is that, remember, we have to balance the charge by adding electron. So what is the oxidation number of hydrogen here? Is 1. Then how many hydrogen is present there? That's 4. So the charge of this hydrogen here is 4, plus what is the charge of this whole compound here? Is -1. So 4 plus -1 will give us what? Plus 3. So that means this whole compound here gave out 3 electrons. Then for this one here, what is the oxidation number of NO? Is 0. Remember, it's a neutral compound. What about this one here? Is also what? 0. 0 plus 0 is going to give us what? 0. So that's to say this guy here has to gain 3 electrons for this part to be balanced or to be equal to this other part. So to balance that, I'll have 3 electron plus 4 hydrogen plus NO3 minus to give us NO plus what? 2H2O. So this is the balanced chemical equation for the reduction. Remember, we are doing two. It's called redox reaction, reduction and oxidation. So we have been able to balance reduction reaction. So let's try out the one for oxidation. So for oxidation, we have Ag to give us Ag plus. So the first thing that comes to our mind is, let's determine the oxidation number. Oxidation number here is 0, here is what? Is 1. And this is a half reaction. Then the second one is, let's balance the atom. If you want to balance the atom, how many silver do we have here? 1. How many silver do we have here is what? Is 1. So the atom already is what? Is balanced. So there is no need for you to add water, and there is no need for you to add hydrogen. The next step is, let's balance the charge. And how do we balance the charge? Remember, by adding what? Electron. What is the oxidation number here? Is 0. What about the oxidation number here is what? Is plus 1. That is to say, we have to add one electron to this other side. This one I've given out one electron already, so we have to add one electron to make this side balance. So we have Ag to give us Ag plus what? 1 electron. So it is wrong for you to write one electron like this, just for you to write plus electron. So this is the balanced chemical equation for the oxidation. Here is oxidation and here is what? Is reduction. You can't leave your answer like this. You have to come to bring your two answers together. We have been able to balance for reduction, and successfully we have been able to balance for oxidation. So what we have to do, we have to balance the overall reaction. But it is wrong for you to have three electrons, this. We don't need electron in the whole reaction. So what you expect to do, we need to eliminate this electron from the whole reaction. Here is 3 electrons, here is 1 electron. So for me to be able to eliminate these 3 electrons, I have to multiply this whole reaction by 3 electrons. I repeat, for me to remove this 3 electrons here, I have to multiply this whole reaction by what? By 3 electrons. So here will be 3, here will be 3, and here will be what? Is 3. So let's write the overall chemical reaction. So we have 3 electrons for the reactant only, 3 electrons plus 4 hydrogen plus NO3 minus plus 3 Ag. That's this very one. Now that's all the reactant. Then it will now give us, our product will be NO plus 2H2O, yes, plus 3 Ag plus what? 3 electron. So that's to say, this 3 electron here has the ability to cancel out this 3 electron. So what are we left with? 4 hydrogen plus NO3 minus plus 3 Ag to give us NO plus 2H2O plus what? 3 Ag. So this is the balanced chemical reaction for this reaction here. Then what you should take note, let's even check if it is correct. How many hydrogen do we have here? Is 4. Let's check the product. How many hydrogen do we have here? Is 4. How many nitrogen do we have here? Is 1. How many nitrogen do we have here? Is 1. How many oxygen do we have here? Oxygen is 3. How many oxygen do we have here? 2, 3. Then let's check for silver. How many silver do we have here? Is 3. Then how many silver do we have here? Silver is as well what? 3. The next step is, let's check for the ion if the electron is balanced. Now for the reactant, this place here is going to give us 4 plus this place here is going to give us -1 plus this place is going to give us what? 0, because it is stable. It's a neutral element, so it is going to give us 0. Then if you check this other side, NO is going to give us 0, H2 is going to give us 0, then here is going to give us what? 3, because it is an ion. Then if you check that, 4 minus 1 is going to give us +3. Then 0 plus 0 plus 3 is going to give us what? +3. That is to say, the chemical reaction is very, very much balanced. Please, try as much as possible to glance through the video again. If you find any part complicated, feel free to drop a DM. I will definitely attend to that. Remember, for in balancing a chemical equation, first of all, check, is it acidic or basic? If it is acidic, these are the steps you follow. First of all, determine the oxidation number of the element. Secondly, write out the half reaction for the equation. Then thirdly, balance the atom. If the oxygen is not balanced, you have to add water. If the hydrogen is not balanced, you you have to add hydrogen ion. Then thirdly, balance the charges by adding what? Electron. Lastly, you have to confirm the number of atoms, confirm the number of electrons if truly the equation is balanced. Don't forget to eliminate the electron. If you have any question regarding all that I've explained, feel free to drop that on my comment section. I will definitely attend to that. Thank you for watching. Stay blessed.